search products fast with BM25 and filters. By the end, you will have a tiny Python product search. You will see BM25 ranking in action. You will add category and price filters that narrow results instantly. I'm Professor Pi, teaching search and information retrieval from basics to advanced in simple Python. BM25 matters because it boosts results you actually want. It optimizes relevance at the top of the list, which is what users judge first. The trade-offs are real. Better ranking can cost CPU and memory when the catalog grows. On a small catalog, you get sub-second queries. At million item scale, you will consider approximate nearest neighbor to keep latency low. Intuitively, BM25 blends how often a word appears and how rare that word is across items. It shines with short product titles and descriptions. It struggles if products lack meaningful text or when synonyms dominate and you need semantic matching. We will build a tiny pipeline that tokenizes products, computes IDF, tries a quick IDF match, upgrades to BM25, and finally applies category and price filters to return the best match for a query. Now we'll tokenize and preview the data. This snippet tokenizes tiny product texts and previews tokens and vocabulary size. It builds 3 aligned lists: the product texts D, their categories cat, and their prices PR, so later filters can reference the same index. The regex find all turns each text into lowercase word tokens stored in TOC. Then it flattens the token lists to compute a quick vocabulary and prints the first product tokens and the vocabulary count. That simple preview gives a tangible sense of what the search engine will operate on and confirms the text is clean enough for scoring and indexing. Next, we compute document frequencies and IDF. This snippet computes document frequency and IDF needed for scoring later. It counts in how many products each token appears using sets per document to avoid overcounting repeats. The IDF is computed with a BM25 style log formula that downweights frequent words and boosts rare ones. The snippet also computes AV, the average document length, which BM25 uses to normalize longer texts. Sorting IDF and printing the top tokens shows which words are most informative in this tiny corpus. That helps you trust the weighting signal used for ranking. Next, we make a simple IDF-based baseline ranking. This snippet ranks products by binary IDF matches for a simple query. The variable Q holds 2 query terms, and the code scores each product by summing IDF values for tokens it contains. Using a set per product ensures each term contributes at most once, which keeps this baseline easy to understand. It then builds SC as pairs of product text and score and sorts them to return the top 2 matches. This gives a fast relevance baseline before full BM25. Seeing the printed pairs lets you compare which products match the query by informative terms alone. Now we upgrade to full BM25 scoring. This snippet upgrades scoring to full Okapi BM25 with term frequency saturation and length normalization. It defines a function that computes the BM25 term weight using K1 to control saturation and B to scale length normalization relative to the average length AV. For each product, it sums IDF times that term weight over the query terms to obtain a BM25 score. It then sorts and shows the top 2 ranked products. If you increase K1, you reward repeated occurrences more. If you raise B, you emphasize document length more. Here the documents are similar length, so length normalization shows mild effects. Finally, we apply category and price filters before ranking. This snippet applies category and price filters before ranking with BM25. It builds IDX as the list of positions for items in the accessory category priced at or below 30, using the shared CAT and PR lists to keep indices aligned. For those candidate indices, it reuses the BM25 scoring function to compute scores with the same query. Sorting and picking the top candidate returns the best match from that filtered set. Tightening the price cutoff reduces candidates and speeds retrieval, but may exclude relevant items. The printed result shows the best accessory under budget that matches the query. Recap: you have a small but complete search pipeline that tokenizes, weights with IDF, ranks with BM25, and filters by category and price. Use this when you need accurate top results on catalog searches before moving to heavy infrastructure. One caveat is scale. As item counts grow, you will need indexing or approximate methods to keep latency low. Next step, tune BM25 K1 and B against real queries and user clicks to find the sweet spot for your catalog. Small changes in K1 change how much repeat terms matter. Small changes in B change length impact. If short practical IR helps your projects, subscribe and watch the rest of the information retrieval series.